All right, welcome back, physicists. Today we're going to take a look at standard velocity B1. We're going to take a look at average speed and velocity. So far we've introduced the idea of displacement. So let's get ourselves started by drawing in a little number line here. Okay, and I'm going to add some positions. So here I've got t equals 0, t equals 1, t equals 2, 3, and 4 seconds. Now, I can represent the displacement between each one of the points by drawing in a little arrow here. I'm going to do that in red. Okay. And these little red arrows, they represent the displacement between two successive points. And so let's calculate what one of those would look like. So let's see, let's do x when t equals 1. And actually, we'll start at t equals 0, and then we'll go to t equals 1. And to figure out that displacement, I need to do x at t equals 1 minus x at t equals 0. So x at t equals 1 is 1 meter, and x at t equals 0 is 0 meters. So I get that the length of that red arrow there is 1 meter. And if you look at all of them, you can see that all these red arrows has a length of 1 meter. Now we know when we're describing the motion of something, it's not only is it important to think about where the object is located and at what times, but also thinking about how much time it takes to go from one point to another point. In other words, we need to think about the time and how the time plays a role. So one question we might want to ask ourselves is, well, if I made a plot of this position as a function of time, I'd end up with a line that looks something like this. Okay. And I can describe the rate. I can describe the rate that x changes. Okay. And we know that the rate that something is changing, when you think about it in a graph, corresponds to the slope of that graph. So if I was trying to figure out the slope of this graph here, I would need to figure out the change in the vertical direction, the change in the horizontal direction, and then divide them. So I can do the same thing for my 2 points up here. So if I needed to figure out now the change in time between those 2 points, I would do 1 second minus 0 seconds gives me 1 second. And if I combine these two numbers for this example, I would have 1 meter divided by 1 second gives me 1 meter per second. Okay. And this tells me, how can I interpret this? Every second that goes by, the displacement changes by plus 1 meter. Starting at 0, a second goes by, 0 to 1. Another second goes by, 1 to 2. Another second goes by, 2 to 3. Another second goes by, 3 to 4. Okay. Now we're going to give this a special name, and we're going to call it the velocity. In fact, we're going to call it the average velocity, because the average velocity lets us find the velocity between any 2 points that we might pick. Now, if our velocity is a constant, like it is for this graph, then the average velocity sort of matches up with the velocity at any one point. We can also come up with the version of this that doesn't have direction, and that would be our average speed. In this case, the average velocity and the average speed are the same. But you can imagine a situation where, let's say I switch the direction of these arrows and I'm moving now from right to left. The average velocity would have a minus sign and the average speed wouldn't, because it's just telling me that rate without the direction. The other thing that's important about the velocity is that you want to make sure that you are doing final minus initial, right? Anytime you figure out the change of something, let me write that the change in anything is the final version of that thing minus the initial, right? Or sometimes you think of it as 2 minus 1. So that's a really important idea as well. And we'll talk a little bit more in a later video about how to take this idea of velocity and connect it back to the graph to represent our work in another way. We'll do that in our next video. Thanks for watching.